Now I would like to welcome Dr. Praveen Kumar Gupta, the
Jiten,
speaker for this second
hello,
session
Dr.
of
Jiten.
this
Your voice is
MBT.
not coming.
Dr. Praveen Kumar Gupta has done his PhD from Civil Engineering Department, and he has
Hello.
mastery in earthquake engineering, dissipation devices for mitigation of seismic risk, experimental test on machinery and RC structures, seismic vulnerability assessment of existing building, sustainable and resilient infrastructure, and low cost structure solutions for developing countries, and rehabilitation of structures. Now, Dr. Praveen Kumar Gupta is working as an assistant professor in National Forensic Science University. As from the name also, you can tell that National Forensic Science University has something to do with the forensic investigation. And just like the name, it is actually doing the investigation of all the infrastructural failure that are taking place in this country. So Dr. Praveen Kumar Gupta has been playing the key role for that position. So now I would like to welcome Dr. Praveen Kumar Gupta to present uh, on this topic for this session.
Yes, published.
Uh, he, I would also like to mention that Dr. Praveen Kumar Gupta has done has been awarded Distinguished Alumni Award in 2023 from Hindustan College of Science and Technology, Mathura. He has done his PhD in 2018 from MIT, Allahabad. He has done his MTech from MIT, Allahabad, and BTech also from APJ Abdul Kalam Technical University. And he has done a lot of research. He has published about 26 journals. He has published about 26 research articles
Hello.
on various prestigious journals and conferences. Now I would like to welcome Dr. Praveen Kumar Gupta to present on the topic seismic resilience to buildings.
Am I audible to you, Dr. Jiten?
Sir, you are not audible.
Hello.
Yes, now you are audible, sir.
Okay, okay. So, very good evening to all
Sir,
of you.
okay, sir.
Okay. I'm grateful to Dr. Jiten and
Dr.
Government Engineering College Buxar for providing me this opportunity to deliver this lecture on the topic of seismic isolations of structure. So, I would like to share my screen. So, are you able to see my screen?
Yes, sir.
Okay, okay, thank you. Okay, so the content of this lecture would include the introduction, some history of seismic isolation used in India, effect of seismic isolation, different types of isolation bearing, and as new code has been provided 1893 2022. Actually, it is 22 part 6, which has been incorporated, in which you will find seismic isolations of bearing as per Indian standards. We can have some demonstration using ETAP, how we can provide the seismic isolation using ETAP. And the last one is the previous study which I have done with my students, in which include the regular building with base isolations. We have also already done mid-story isolations and bridges also. So first, the isolations has been started in earlier a 19 uh, 1909 by J.A. Calendris. He's a medical doctor, but he has had some thought that if the building has been separated from their base, so it can be more resistance to earthquake. So he filed a patent, and it was a British patent. And after filing the British patents, uh, the idea has been more elaborated, and we have incorporated isolations bearing nowadays. So this was idea was by Dr. J. Calentris. History, if you see the history of seismic isolation, in 1885, Japan has already started the wooden structure, because there are a lot of casualty happen in Japan. So they have started providing the sand layer over the base, so that they can protect their structures. And then in 1909, we have already seen that the Professor Dr. Clandris has provided first patent for the seismic isolation. Later on, New Zealand also worked, Italy has also worked, USA has also worked on base isolations. And in 1975, New Zealand has invented lead rubber bearing, with a very advanced isolation bearing are being used nowadays. And later on, they have provided more studies on that, and they have provided more isolation bearings. And these nowadays we have a smart isolations also provided, with having shape memory allies. So the objective of the isolation is to protect the structure from earthquake. But there are certain limitations. Whenever you use the isolation bearing, it reduces the earthquake. And at the same time, you have a problem of larger displacement in the building. So in order to control that displacement, you have to protect the structure. You have to control the structure. Your structure should be within the allowable limit of your Indian standard. Whatever the country the code is being used, you have to protect your structure with a limited displacement. So these are the difficulties whenever you provide the seismic isolation. So that's why the smarter isolations has been incorporated in these studies. First seismic, if you see, the seismic isolation bearings are now being used. But if you see the first building which has been incorporated after Bhuj earthquake, which has been happened in the Gujarat. And you will find that there is a Bhuj civil hospital, in which 280 lead rubber bearings has been installed, and now it has been protected from the seismic activities. If you see the isolation, so you will find that we have a such kind of response spectrum. And if you see the acceleration response spectrum perspective, isolation is the technique by which you are lengthening the time period of the structure. Whenever you are having any kind of structure, you will calculate the time period of the building using whatever the code you are using, whether you are if in India, so you have a IS code 1893 part 1, in which you have a formula for the time period. Okay. And if you do the model analysis, you will find the time period of the building. But what is our objective? Our objective is to lengthen the time period of the structure. So if you lengthen the time period of the structure, your base shear is getting reduced. If you see this red dot, this base shear is getting reduced. And at the same time, if you see, there are three lines over there, and this has been this the first
नहीं
line.
नहीं यार
if you are
जाएगा तो
if
वही
you
है कि
see,
मैकेनिकल को लैब असिस्टेंट नहीं उनका बात मानेगा और
uh,
इतना ना उस
भाषण
दौरान
some voice are coming. Jitin, can you mute all this voice?
Yes, sir. Muted, muted.
Yeah, okay. So if you see this diagram, the base shear is getting reduced by lengthening the time period. The T1 is the time period of the existing building, and you will find there is a higher base shear. But if you provide the isolation bearing, your time period has will be increased. At the same time, your base shear will be reduced. Hello. Yes. So by shifting the time period, you can take the advantage of isolation. And these three lines at the same time, the damping is also provide the very critical role, because our isolation bearing is nothing but you are adding certain additional damping to the structure. So by increasing the damping, you can additionally reduce the base shears also. If you if you see this diagram, in which if you see the displacement response spectrum perspective, so by that time, if you are increasing the time period, so what is the main problem in isolation? You will having the increase value of displacement. So that is the biggest problem. So how you can incorporate this problem? By adding additional damping to the structure, you can reduce the displacement, increase displacement also. So by increasing the time period, you can have a lesser base shear, and by adding some more damping into the structure, you can reduce the displacement of the building also. If you see the effect of soil condition in the structure, if you are having two types of building, which is without isolation, another one is with isolations. So if you see this diagram, you will find that without uh, without isolation, soft soil having lesser response, but at the same time, the stiff soil having more response, and soft soil having less response. But at the same time, if you will see the isolation bearings, with the isolation bearing, what it will happen in the with isolation bearing, uh, with having soft soil having the larger response than the stiff soil. So this is the effect. If you see, our isolation bearing has been categorized into two parts: elastomeric bearing as well as the friction based bearing. So if you first we will see the elastomeric bearing. Elastomeric bearings are consist of alternate layer of natural and synthetic rubber and steel plates. So this is the first type of rubber bearing, in which we will provide the alternate layer of natural rubber and steel plates. Okay. And the behavior of this particular bearing, you can see this particular diagram. This is the force deformation diagram, and this is nothing but the energy dissipation. How this particular bearing can reduce the response. This is the mechanism by which the isolation bearing reduces the response. So it is not the hysteresis loop is very the area of hysteresis loop is very less. So this particular bearing having low damping, and it does not reduces so much response. So we will see the additional bearing, which is called high damping rubber bearing, in which you will find the damping ratio up to 20%. So it is the additional viscous damping which you are going to provide in your structure, which can dissipate the significant amount of energy, seismic energy, and you can protect your structure from earthquake. So if you will see the hysteresis loop, so the area of this particular hysteresis loop is bigger than the previous one. So this region reduces the seismic response of the structure, and also having lesser displacement into the structure. Another one is the lead rubber bearing. This is also another kind of rubber bearing, in which is the lead plug is insulated, and this lead plug dissipate the energy, which is a similar kind of HDRB bearing. But this particular the role of lead plug is to dissipate the energy, and it provide the heating element to this material. And the loop of this is the it is a kind of bilinear behavior, and by this bilinear behavior, HTRB bearing reduces the response of the structure. The another type is the sliding bearings. Sliding bearings allow the relative displacement between the structure and substructure through the sliding surface. So if you know the simple sliding, what is the purpose of sliding? Whenever you have any kind of friction, so definitely there will be some kind of energy dissipation. So this particular bearing based on the our Coulomb friction, in which the energy dissipated by friction. So what we are doing, we are just providing different type of sliding bearing, in which we have provided the friction material, okay, that provides the friction between two surfaces. So there are four types of sliding bearing: flat sliding bearing, friction pendulum sliding bearing, and double concave friction pendulum bearing, and triple concave friction bearing. This is the advanced bearing, which is not in proper use, but for the research purpose this bearing is widely used by many researchers. So if you see the flat sliding bearing, it is a simple flat surface with a low friction material like PTFE. So if you see the force deformation behavior of this particular bearing, this is a also kind of bilinear and non-linear behavior, but you will find that there is a permanent deformation into this particular bearing. So this is the when the uh, this particular bearing having some displacement, it does not regain its original position. So that is the biggest problem of this sliding bearing, it having a permanent deformation whenever is the extreme loading occur into the structure. So that's why we have a different type of friction pendulum system, in which the surface is supported on a pendula, and this pendulum is slided over between this ring. And due to this restored their deformation into the structure. So this is the advantage over the natural simple sliding bearing, and with the friction pendulum system. So it regained its original positions. If you see the double concave friction pendulum bearing, this is two concave sliding surface suitable for large displacement. So whenever you have a extreme loading, so this type of setup will be prepared for our double concave surface uh, friction pendulum bearing. So this particular slider will move this pendula, and the radius of the pendula is will be designed based on the loading. So this is called double concave friction pendulum system. If you see the triple concave, so this is the additional pendula provided over there, so that it can move more displacement, and the structure can be protected. And when the earthquake passes over this particular structure, it will regain its original position. So that's why it is more advantageous than double concave friction pendulum bearing. So triple concave having very large displacement, and it's also regain its original positions. Another bearing is called SMA bearing, in which this is the advanced type of bearing, and which because whenever you provide any kind of isolation bearing, as I have already told you that it having a deformations, and that deformations after the earthquake having maybe a permanent kind of deformation. So to protect, to improve that deformation, what we can do, safe memory alloy uh, can be provided, can be inbuilt into the isolator, so that it can improve their capacity of recentering. So the basic property of shape memory alloy, it provides the flexibility, it having large energy dissipation, and the most advantageous property of SMA is the recentering ability. So whenever you provide the SMA into the bearing, it having zero residual displacement. So that's why this particular is SMA bearing is quite popular among the researcher. That SMA with it is a combination of lead rubber bearing with SMA bars or SMA wires, friction pendulum with SMA wires, and it enhances the recentering capability during the strong earthquake. So if you see this particular SMA bearing in which the cross wires, and these wires are SMA wires, has been provided to protect it from the permanent deformation. So whenever the earthquake will come, it will deform. The isolation bearing will deform, but these SMA wire will activate and it will come into the recentering properties has been provided by SMA wire, so that the permanent deformation will not occur in this type of bearings. Here, if you see, this is the sliding bearing. You can see it is a friction pendulum system, and in which a SMA wire has been arranged in such a manner that whenever this particular slider will move to and fro through this pendula of radius, so this SMA wires will activate, and this SMA wire will try to attract towards this friction pendulum system, so it will not having any kind of permanent deformation due to these wires, and it will also dissipate the energy during the earthquake. Sometimes we provide the isolation bearing base, but you can also provide the isolation bearing at the mid level, and many researchers have also provided base isolation, mid isolation, and they have combined base isolation and mid isolation. We will discuss it in the next slide. So mid-story isolation is a structural engineering technique where the seismic isolators are installed at intermediate floor level, and the isolated portion, upper portion of the structure from lower portion, allowing each part to respond differently among the ground motion. So during the earthquake, lower story anchor directly to the ground and experience majority of energy, while isolated upper story move independently with significantly reduced vibrations. So this the role of is isolation is that to decouple the structure from the upper portion. So the lower portion will decouple from the upper portion. The upper portion move to and fro, and it will not the acceleration will not transmit at the upper level. So this is quite useful for high damping rubber bearing. So high damping rubber bearing, as we already discussed, is provide the additional damping. So additional damping in form of viscous damping. So if you see this particular high damping rubber, it is the alternate layer of steel and rubber, and it also having the vertical stability. Vertical stability means whatever the vertical load coming on the structure, it will resist that part, and as well as the horizontal stiffness is provided by the steel and rubber plates. If you see the numerical modeling of high damping rubber bearing, the numerical modeling can be done by for this bilinear behavior of isolation bearing, in which you will find the initial stiffness that is denoted by K1, and this is the second stiffness which is called K2, and that's why it is called bilinear, because there are two linear part in coming. First one is K1 having this part is having K1 stiffness, and this part is K2 stiffness. That's why this particular graph is called bilinear modeling of high damping rubber bearing, because there are two stiffnesses are coming in this particular picture. So by this behavior of high damping rubber bearing, the loop formed by the bearing, and the area of this particular loop will be called as energy dissipated by the high damping rubber bearing. So if if you see the modeling of high damping rubber bearing, so first what you have to do, you have to choose the target time period of the isolation. Means let us say your building is 0.5 second, yeah, 0.8 second. So for what time period of structure you are going to design your isolation bearing. So you have to decide, because your time period is nothing but reciprocal of frequency. So first you have to identify which kind of ground motions, which kind of earthquake we are targeting, so that we can protect our structure. So it depends upon in which zone you are working. So for that particular zone, you should have an idea that how we can protect our structure. So in order to that, you have to target the time period of the building. So how you can determine the stiffness of the isolator? So we know the T barabar 2 pi under root m by k, where m is the mass of the structure which is directly supported on the isolation bearing. So if you want to place 10 number of isolator, so you have to accordingly calculate the K effective. Okay, so this mass is the whole mass of the building or bridge, whichever you are want to provide. So the substructure mass is to be calculated, and then the mass you can calculate that T you can target. Let us say I'm targeting 2.5 second. So here it will be 2.5. Here the mass of the building you can calculate, and then you will find out the K effective for which our isolation bearing should be designed. By using this formula, energy dissipated, here you can have 2 pi k effective you can calculate from here, and d initial you can assume. And the damping xi is the damping ratio means for what kind of damping you are going to provide into the isolation bearing. So first you will put here, so you will find the value of ed, and based on the value of ed you can put the characteristic strength, which is characteristic strength means how the initial displacement will be propagated to the final one, is the second stiffness how you will come. So this characteristic strength you can find out using this formula, and then you can have the post yield stiffness. So let us say you are designing the high damping rubber bearing. So in that case you have to provide the K2 by K1 ratio 0.16 for high damping rubber bearing. And if you're designing the lead rubber bearing, so you have to keep this ratio 0.1, so that you can get the value of this yield force Fy is equals to K1 into dy. Initially you have to provide the dy is 0, and then you can calculate the yield displacement. And this procedure will be repeated, because you will not get the direct this Fy. You have to give many iteration, unless until you are going to have repeated values of the displacement and yield force. So this is the iterative method to model a high damping rubber bearing and lead rubber bearing. Similarly, this formula can be used if you are modeling the friction pendulum system. So in this, you have to determine the radius of the pendula using T barabar 2 pi under root R by G, where R will be the radius of that pendula in which your slider will be moving. So this is the formula for to determine the R. And if you are having R, then you can find out the K effective, and K effective is nothing but W by R. So R you have calculated from this formula, and W is the weight on the isolator which you are going to support. And the coefficient of friction, you can use this particular formula to determine the coefficient of friction. And after determining this, you will having these values K1 and K effective and the yield force. You can provide this particular either in SAP 2000 or ETAB. You can use these values to model any kind of isolation bearings. So case study which we have done for the regular building. So we have selected this particular regular building in which we have size of beam, this grade of concrete, length of the beam, size of the column, different size of the column has been provided, grade of concrete, rebar, and flow diaphragm is rigid. And we have modeled this particular building having these amount of reinforcement, and these ground motion has been selected and determined. This ground motion has been selected and determined from peer ground motion database. So there is a website, peer ground motion database, in which you can download the real time earthquake data. Because whenever you are you are going to perform any kind of non-linear time history analysis, so in that you have to record the real ground motion data, and these data can be scaled to your seismic zone. Otherwise, if you are not scaling, if you want to capture the real effect of that particular ground motion, you can use unscaled ground motion. So it depends what kind of study you are going to have. Many researchers do unscaled ground motion, many researchers do for scaled ground motion. So this kind of data can be downloaded from peer ground motion database. Okay. So if you see, if you look at this particular ground motion, these are 8 ground motion has been used in this study, and there is a variety of the ground motion, because these ground motion having a different PGA, different PGV, and if you see this acceleration ratio, Vmax upon Amax. So PGA stands for peak ground acceleration. What was the peak ground acceleration of that particular ground motion? And at that time, what was the peak ground velocity of that particular ground motion? So PGA, PGV, if you see Vmax upon A max ratio, so it gives the idea about Vmax upon A max, gives the idea about the characteristics of the ground motions. Because whenever you download the ground motion, you will not have an idea what kind of ground motion we are having. So once you analyze this data, what is the peak ground velocity, what is the peak ground acceleration of that particular ground motion, then you will be categorize these type of ground motion. So whether it is near fault ground motion, far fault ground motion, this can be also recognized using these parameter. This is not the exact parameter, but more or less, if you have an idea about Vmax upon Amax ratio, then you will certainly say that this particular ground motion may fall under near field ground motion or far field ground motion. So this is the set of the ground motion has been done in the studies, and in some of the ground motions are near fault, and some of the ground motions are far field ground motion. So basically, the study was done for regular building, C-shaped building, L-shaped building, and the most important thing, after doing so many iteration in the design, we have observed these parameter, which is going to be provided in our software, whether we are going to provide using ETAB or SAP 2000. These are the important parameter which you will derive from the equation which I have already discussed. Based on that parameter, you will using those equations, you will find this type of data. Target time period 2.5 second. What was the mass of on that particular isolator? What damping ratio we have assumed? So we have assumed 20% damping. So we have taken 0.2. K effective has been determined using the formula T barabar 2 pi under root m by K effective, and K1 using that formula, and Fy using those formulas. And then we have this kind of information which we can incorporate in our software, so that we can model the isolation bearings. After doing analysis using these ground motion, we have observed important results over here. So if you see the buildings having without bearing, so this blue color and green colors having base isolated buildings, and this non-isolated building having these x directions and y direction. So if you see the ratios, inter-story drift ratio, which is a very important parameter to design any kind of buildings. So this is the significant reduction in the inter-story drift ratio has been observed in isolated building. So non-isolated building having more ratio, but in this isolated building having lesser inter-story drift ratio. Similarly, these are for different ground motions. So for GM1, GM2, GM3, which we have shown in earlier slide. So you can see there is a significant reduction in the interstory drift ratio if you are using this high damping rubbers bearing. So we have some observations that the fundamental time period was increased from 0.83 second to 2.6 seconds for pulse type ground motions. As I already discussed that whenever we use any kind ground motion, so we have to categorize that ground motion based on our seismic zone. And if we are not using any kind of seismic zone, so we should categorize our ground motion whether it is near fault are pulse type or non-pulse type ground motion. So in this particular study, the ground motion has been classified and it has been observed that the average increase in story displacement. Story displacement, I have already told that the story displacement may increase, but if you see the drift can be significantly reduced. So in this particular study, what was done, the higher PGV value, peak ground velocity value, are generally correlated with higher interdrift ratio in non-isolated models. And however, regardless of PGV, the low values of IDR were found in the base isolated model, indicating the effectiveness of base isolation in controlling inter-story drift ratio. Additionally, it was discovered that the higher PGV values generally correlated with higher interstory drift ratio in non-isolated model. The seismic energy of ground motion is directly correlated with the base shear and story displacement, and force deformation behavior is also elongated in higher PGV, because whenever you have a high pulse of velocity, so your force deformation behavior means your displacement will be higher. That's why the force deformation elongates. So we have done another study, which is the case study for inter-story isolated building. So in which we have selected a building from literature, and we have modeled a 16-story building, and these are the properties of high damping. Sorry, these are the property of this particular 16-story building, and we have categorized this particular building as a Class B building, and we have a grade of concrete M30, and these are the live loads and dead loads are provided into the building. And first the building has been designed as per IS code, and then the ground motion has been applied. So if you see, this particular study has been having four models. So first model was without any kind of device, means we have not provided any kind of device. The second model is the base isolated model, in which we have provided the isolation bearing at the base. And the third model is that in which we have not provided any kind of isolation at the base, but we have provided somewhere intermediate level into the building. And this particular is the new staggered isolation bearing, in which we have combined the base isolation as well as the inter-story isolation. So we what we have done, we have provided four type of structures. The first structure was without any kind of isolation. The second structure was base isolation. The third structure was mid-story isolation, and the fourth is the combination of mid-story isolation and base isolation. So we have investigated the effect of these type of building, and how this building, which kind of combination is more suitable for protecting the structure from the earthquake. So when the studies has been done, it has been observed very mixed type of response. So what we have done, first we have done the modal analysis to determine the mode shape of the structure. So the first two modes were coming translation, and the third mode coming intentional mode. So these are the mode shapes of the building has been obtained using modal analysis, and these are the ground motions. So we have categorized our ground motions depending upon the peak ground velocity. So peak ground velocity is the main parameter which can significantly affect the response of the structure. So we have a two range of peak ground velocity, one ranging from 40 centimeter to 130 centimeter, and the another is group is less than 40 centimeter per second. So these ground motions has been categorized group 1, and the next ground motion has been categorized group 2, and these two group of ground motion has been downloaded from peer database, and the ground motion has been selected from the literature based on the peak ground velocity. And if you see the results, the result was quite mixed, that because we are using four types of buildings. First one is the non-isolated building. Non-isolated building having larger displacement, and then the mid-story isolation. If you see the gray line in the mid-story isolation, so some up to some height, the base isolated building having lesser displacement, and the NSSI also having a combined effect, because in if you see the NSSI graph, you will find it having two level of isolation. So if you see this particular graph, this graph is increasing suddenly, and this is because at this level the isolation has been provided, and after that this response has been reduced because the inter-story drift ratio is less, providing to this. Similarly, if you see this particular graph for drift, so the drift is coming less. But if you see this particular graph at story level 25, so this is having a sudden displacement. This sudden displacement shows the displacement of the isolator. It is not the displacement of the building, because building is connected to the isolator, so that displacement, that interstory drift ratio is not considered because it is the displacement of the isolator. That's why this graph is suddenly coming. This graph is suddenly coming. So this particular values are coming from the isolation level, and this is the actual drift ratio has been obtained. Similarly, if you see this particular graphs in El Centro ground motions number 5, this was the force deformation behavior. So force deformation behavior, because we have modeled a high damping rubber bearing, so in which uh, provided uh, we have provided high damping rubber bearing at both the level, mid story level and base isolation and NSI. All the bearings has been combined and their behavior has been combined. So it has been observed that the mid story isolations has been found suitable for energy dissipation for this particular ground motions. Similarly, if you see the group 2 ground motions, so again you will see that group 2 ground motions having NSI having lesser effect, because we have provided two additional damping, because we have provided at mid story level, we have provided at base level, so this particular damping has been increased. So that's why the NSI model having lesser loop. And but at the same time, if you see this orange graph having larger loop, because the mid story having a single damping, that's why it dissipated more energy. So if you look at the idea, and then if you want to select which kind of isolation bearing, which kind of system is more suitable while selecting and deciding the base isolation or mid story isolation are, so there are various parameter which we have to consider: drift, displacement story, and energy dissipation. So this is the mixed kind of behaviors. In some cases, storage displacement and storage shear is coming good. But if you see the NSI, so NSI having a great effect if you are having the ground motion having 40 centimeter to peak ground velocity ranging from 40 centimeter per second to 130 centimeter per second. So if you have a peak ground velocity less than 40 centimeter, so either you can use the mid story isolation or base isolation, so both having two ticks only. Okay, so this type of studies has been done uh, by providing the isolation bearing. Case study for isolated curved beams. So we have also modeled a curved bridge in which we have provided the isolation bearing, and this curved bridge was a single chamber box girder bridge having total length of 165 meter. The total number of span was 7, and end span and their length was 20 meter. And intermediate span was 5. Total intermediate span was 5, and the length of intermediate span was 25 meter, and the radius of curvature of bridge of 300 meter, and the moment of inertia and cross section pier values has been taken, this, and the pier were resting on the rocky strata, so we have taken the fixed base at during the modeling of the curve. So this is the line diagram in which the isolation bearing has been modeled. So this is the curve which has been modeled, and this portion is having deck, and the isolation bearing has been provided at pier level. So at top and bottom, you can see here the isolation bearing has been provided. So on the abutment, two bearings has been provided, and at if you see at the pier, total number of bearings provided 4 at each pier. So if you calculate the total number of bearings, so 4, 4, 4. So at each pier we have a 4 bearings, and at each abutment we have provided 2 number of isolation bearing. So this is the extrude view models of this particular curved bridge in which we have modeled and provided the isolation bearings. And during this study, we have these kind of ground motion characteristics, and these ground motion has been selected from the literature. But this particular ground motion having different characteristics. This particular ground motions having near field without forward directivity effect, and near field with forward directivity effect. So this ground motion Ericsson Turkey is very impulsive type of ground motion. You can see the predominant period of these ground motions is very high. And if you see the ratio of peak ground velocity and peak ground acceleration, it is also very high. So by seeing the property of the ground motion, you can see the characteristics of this particular ground motions. So this study has been done, and in this particular study, the effect of time period, if you are varying the time period of the structure, means if you are shifting the time period of the structure by providing the isolation, so different models has been prepared, and these models has been investigated with different combinations, means you have a combination of 1.5 time period and damping 0.1. We have a time period, means four variation of this and four variation of this, means 16 models has been prepared, and this study has been done. So if you see this particular diagram, figure number A, so you will find that by varying the damping ratio, means if you are increasing the damping ratio of the isolation bearing, your displacement, bearing displacement will get reduced. But at the same time, if you are seeing this particular displacement in crossing and it started increasing over here, so this is kind of optimizations of the bearing, means you cannot provide more than 20% of the damping into the bearing. So that's why after a sudden decrease it started increase, means there is a some kind of optimizations in this particular isolation bearing. So based on that we can have an idea that we can fix the time period up to we can fix the damping ratio up to 20%. if you see the if you see the time period of the structure, by increasing the time period of the structure, you are having larger displacement. But you cannot having more displacement, because there is a limitations of limitation in the building or bridges. So you have to target your target design displacement, you can say the design displacement of the bridge, and based on that you can pick your time period value. So this gives the idea that on increasing the damping ratio, our displacement is decreasing, and by increasing the time period, our displacement is increasing. And so damping reduces the displacement, time period increases the displacement. At the same time, the forces are reduces. But if you see by increasing the time period, the forces are gradually decreasing. So this is the effect which gives the idea about the time period of the structure. By increasing the time period of structure, you are having lesser forces, but at the same time you will find you are having more displacement into the structure. So your aim is not only to protect the structure from the forces, you have to take the displacement criteria also. So in order to reduce the forces, aim as a structural engineer, you can reduce the forces, but at the same time you have to also protect your structure from the displacement. So in that case, you have to do some optimizations while designing the isolation bearings. We have also done, because it is a curved bridge, so there might be a torsional moment in the bridges. So torsional moment is also getting reduced up to certain level, up to certain damping, and thereafter it increases. So the response of the bridges is certainly depending upon the time period and damping ratio of the isolation bearings. This is the effect of bidirectional loading. So the effect of bidirectional loading is a kind of effect. If you have download the ground motion, you will find six directions. Means you have a x direction values, you have a y direction value, means two translations values, and one vertical directions value. At the same time, you will find the rotational component of the ground motion, because we have a 6 degree of freedom. So we will have six values of the ground motion. So but how you are going to apply the ground motion, that is very important. Whether you are going to provide the unidirectional ground motion or bidirectional ground motion or tridirectional ground motion. So our code has already given the idea that if you are doing any kind of advanced analysis and the structure is more vulnerable to main other ground motions directions also, in order to that you can provide bidirectional and tridirectional ground motions also. So if you see, if you are designing any kind of building, so this particular blue line is the actual response while the earthquake. So this particular earthquake touches the red line, and this red line is the maximum displacement of the bearing under the bidirectional loading. So if any engineer design the bearing uh, by considering only unidirectional, their design is going to fail, because this particular, the real time history is crosses the black line, and this black line is the envelope of unidirectional, and this red line is the envelope of bidirectional loading. So the red line, if you are designing your building bearing considering the bidirectional loading response, so your bearing will not fail in this horizontal component. And if you see, the high damping rubber bearing significantly reduces the force transmitted to pier deck displacement, and the deck displacement has been increased, as we have already discussed. If you are providing the isolator, there will be a problem of increase in the deck displacement or inter your story displacement in the buildings. We have this code, seismic isolation, as per IS 1893. It is a very small code, and I think it is around 10 to 8 pages code, which I have already covered. These equations are has been given over there, and you can refer this particular code whenever you design any kind of isolation bearings while designing of lead rubber. But there is a limitation of this particular code, is that it is only having lead rubber bearing or high damping rubber bearing. Means you can design only rubber bearing, and you can model this particular bearing as a bilinear modeling, which I have already covered in the earlier slide. So some software demonstration we can do over here, and these were references. Thank you for your attention. And if you have questions, so you can discuss, then you can go for software demonstrations for 2 minutes.
If you have any query, please ask to sir. or you can write in the chat box. If you have any doubt, dear participants, if you have any doubt, sir have finished his session. Very nice session, very informative session. I thanks Praveen sir. Your presentation is really very informative. So
Thank you.
if any question is there, you can feel free to ask from the question, sir. Or if any network issue is there, you can write in the chat box also.
Okay, so I think we should go for some software demonstration where we can find some link and yeah, one chapter. Yeah, which one will be more suitable isolation, either base isolation or mid-story isolation? Okay, actually, mid-story isolations, if you see the mid-story isolation, so these type of isolation is some restrictions. Means, let us say you have a any already constructed building and you want to extend you. Uh, uh, yes. Yeah, if you have any already constructed building and you want to extend that particular building, so in that case you can provide the mid-story isolation. Otherwise, from the starting, the base isolation is quite effective, but having some limitation that you should control the deflection as well.
Okay, sir. Sir, can you show some demonstration which you were
Yes,
saying?
yes, yes. Yeah. So are you able to see my screen? Dr. Jiten, are you able to see my screen?
Yes, we are able to see the screen.
Okay, okay, great.
Sir, one question is came here.
Okay.
Which one will be more suitable isolation, either?
Yes, yes. Either base isolation or mid-story isolation. That I already answered. That if you are having already an existing building, so in that case you can provide the mid-story isolation because you cannot dismantle the building. So after that, after providing the top story isolation, you can construct the building. But in that case, you have to analyze the building accordingly. And if you are constructing the new building, so you can provide the base isolation over there. So this is the building which we have already designed and analyzed. and in which first what you have to do whenever you are going to design any kind of isolation. So first you have to do the non-isolated building model. So in the non-isolated building model, what you have to do, if you see the elevation over here, so this is the joint base, and here uh, we can have a isolation bearing. So here we can provide the joint, and we can provide the isolation bearing. Okay, so first you have to determine the self weight of the building. So self weight of the building include dead load and some percentage of live load that you have to incorporate. So how you can calculate the dead load and live load? First, you have to provide the simply supported joint over all the supports, and you have to do the simple analyze. And if you go to the set load, so you have to only perform the dead load analysis, or you can have a combination of dead load plus live load. And based on that, whatever the reactions are coming. Okay, so that reactions you can calculate in z directions, and this will be the vertical load coming on the structure. Okay, and after once you calculated the load on the structure, you have an idea that this is my mass of the structure. And then what you can do, you can calculate the value of k effective. How we have discussed t barabar 2 pi under root m by k. This is the simple formula by which you can calculate the K effective. So K effective is what we have to select which kind of isolator we are going to provide. So in order to that, we have to determine the value of K effective. So the K effective can be determined by T is equals to 2 pi under root m by K, where T is the assumed value. T is your assumed value, means you are targeting 2.5 second of building or 3-second building. So by using that formula, you can determine the value of K effective. So T is known to you, M is known to you. If you are putting the value of M, what is M? How, if you are providing the fixed support over here, so you will having an idea what kind of vertical load coming on the structure, and that will be in kilonewton. Then if you will divide it by g, you will get the mass of the building. Okay, and then you can calculate the value of k effective, and otherwise you can directly put the value of w, which is in coming the kilonewton. Then you will have an idea about k effective. After getting k effective, you can shift the time period of the structure. Okay, so this is the second step, and you have calculated the k effective. Now if you are putting this particular k effective, so then you will have an idea my building has been shifted from 0.8 second to, let us say, 0.25 second. So how you are going to provide this K effective? So first you have to assign this particular isolation bearing into the system. So if you see, we have already provided the isolation bearing over here. If you click on this, so this is my property, link property over here. If you click on this here, so this is my isolation bearing in which I have provided hdrb4. So if I would like to see the values of this particular, so I will go for define section property, and in the section property, link support property. So the link support property, basically we provide the link as a isolator. So if you click on this link support property, there are high damping rubber bearing has been provided over here. So let us say I'm just adding one new property, for example. So how we are going to fix over here? So if you see here, there are so many uh, devices are available. Here the damper is available, the damper bilinear, damper friction spring gap, hook, multilinear elastic, multi. So which we are going to select? So either you can use the high damping rubber bearing isolator directly, or you can use the plastic pin. Plastic pin is the idea in which you have done already the bilinear modeling. So if you see the directions, so the isolation bearing having three directions. So U1, U2, U3. So U1 is the vertical direction, U2 and U3 are the horizontal direction. So what is this stiffness? This stiffness is nothing but the flexibility to the isolation bearing, flexibility to your building. So in which direction you are going to provide the flexibility? This is not your vertical stiffness. This is your horizontal stiffness. So you have to click on the directional property U2 and U3. So if you click on here, you will find data. So how this data? This effectiveness damping and effective stiffness. So effective damping, what you have calculated using K, T is equals to 2 pi under root M by K. So K is the K effective damping, which you will put over here. And damping you have to assume, let us say you want to do many iteration. So first you will take 10% damping, 15% damping, 20% damping, and so on. So you can put here your damping ratio here. Now, this was the only linear property, but we have already discussed non-linear things also. Means how we are going to provide the initial stiffness, that is K1. So the non-linear, this envelope, non-linear gives the idea about the K1, which which you will calculate the equations we have already discussed, and that is the yield strength Qi, and the post yield stiffness ratio, that is Q2 by K1 ratio. And K2 by K1 ratio can be put over here for high damping rubber bearing 0.167, and if you are modeling the lead rubber bearing, you can put over 0.16. And after putting this, you will having the property in all the directions. And other direction you have to remain fixed. So you have to fix this all the directions, because I am providing my flexibility in the directions of horizontal. So horizontal can be in X direction, so horizontal can be Y direction. So this directional property is very important while designing any kind of isolator. So you have to put over, if you see my properties I have already provided over here, so you can check. I have provided my effective stiffness 302.025, which I have calculated from formula T rubber 2 pi under root m by K. I have assumed the damping ratio 0.15. Okay, the stiffness I have calculated, means that is your initial stiffness K1, and the yield strength is the K1 into dy, which I have calculated from the that equations we have discussed, and this is the post yield stiffness ratio. So here you can put the post yield stiffness ratio 0.167 or 0.1. You can put over here, and then you can having this properties. This is called nonlinear property of the system. Okay, so this is the high damping rubber bearing, and after that, once you have provided the high damping rubber bearing, so then you can, then if you want to draw, so how you will draw the links? So you, once you will define, so then you will having this kind of window, and here you will find your defined properties HDRB1, HDRB2, and then you can select, and you can provide the high damping rubber bearing. Let us say I'm just joining these two joints. Okay, so you can see this bearing has been provided. I can draw anywhere, means where you want to provide this kind of link, you can provide this kind of link. So you can provide, so you will see here, you are able to see the, we have provided the high damping rubber bearing. So but we cannot provide in diagonal directions. We have to provide the damping in vertical directions, because if you see, the isolation bearing is provided under the superstructure. So I'm just showing how, if you are selecting this link, so it can be drawn, and this is your isolation bearings. You can see. Okay. And here in this particular, we have already provided the high damping rubber bearing at this end. If you see the 3D plane, so you will find here I have already provided. This is at the base. Okay. So after providing this property, you have to define the function. After defining this property, you should define the time history analysis, so time history functions. So that functions you can download from peer ground motion database, and you can provide this property over here. And if you want to see how this ground motion will look like, so we can have any kind of ground motion we can take. I think the ground motions is not available over here, but I can tell you the procedure. The time history function can be defined from, if you see from file, you can choose any function over here, and you can select your ground motions here. And then once you click, it will be shown to here. And you can put, after defining the ground motion, you will have to define the load cases. That is load case. That load case will come under add new load cases, and here you will have time history function. If you see here, in load cases, you have a linear static, linear, non-linear static, non-linear stage construction. So in which you have to select the time history function. So in the time history function, if you divide, here you will find some acceleration u1, u2, u3, and this kind of ground motions. So already defined ground motions. Here you have to put the scale factor if you are using ETAP. So here you have to put 9810. If you are using the SAP 2000, then you have to put here 9.81, and here you have to put non-linear direct integration. So there might be some parameter. So if you are providing unidirectional, so you have to add only u1 direction. If you are providing bidirectional, so you have to simultaneously pick u2 directions also. And here you can put the ground motions and scale factor 9810, and here the output step is the number of step, means let us say earthquake is 40 second, and the step size is 0.5. So accordingly you have to divide the 40 second into 0.05 seconds. So you will find the number of steps. So let us say it is 2000 step. So in which you have to put 2000. It is 0.5 is the durations of each pulse. So you will find over here. And damping, you have to provide the specific damping and time period, which you can get from time period, first mode of time period, second mode of time period. Here you can provide the damping ratios, so you can put the value. If you see the time integration method, so there are different method: Newmark beta method, Wilson method, collision method, Hibbeler-Horst alpha method. So let us say if you are using the by default method, so for convergence you have to provide here minus 0.33 values, so that your time history will be converged. Otherwise maybe that your entire time history will not run, and the program failed. So in that case, for the convergence, you have to provide this alpha value minus 0.33, and the non-linear time period parameter you can take as default. Okay, and then you can run the cases. So we have already run these cases, and you can see the after analyze you can go for the analyze case, and whatever the load cases you have made, you will find here in the load cases history here. This is the load case we have created. So you will find the load case 1, load case 3, load case 4, and then you will run on. So it will take time to run the analysis, and then you will be able to find out the drift and displacement of this particular building. Okay, for analyzing, because it will take several minutes while performing the nonlinear time history analysis, and for the result you can find out the results over here, story response plot. You can find out the drift, displacement, all these you will find here. And if you want to see the behavior of the bearing, so in this function quick hysteresis you will find the behavior of the bearings. So here you can find out the results. Okay, because it will take time to analyze the structure. So if you have any doubt, you can ask me.
Yes, please
And
raise. If you have any question, please ask.
yeah, yeah, you can also ask in later on if you have my email ID and contact number, you can also contact for any clarification.
Yes.
Kindly enter your contact number and email ID in the box.
Okay, okay. I'm just entering the my email ID, and so this is my email ID and my contact number.
Thank you, sir.
Okay. In later on, if you are working on the ETAP and you are modeling any kind of isolation bearing, because it requires time, and before that you have to model. First, you have to model your structure as per Indian standard. You have to check all the conditions are satisfying, and then you have to provide the isolator. So it requires more time and more analysis. So it cannot be done right now, but if you are facing any problem, you can discuss me, you can collaborate with me. If you are doing any kind of research in this area, we can discuss anytime.
One question from me. Can
Yes,
this
yes.
be used with, can ETAPs be replaced with StatPro?
No, no, no. Actually, ETAP cannot be replaced with StatPro because when I was you I have used the StatPro. This kind of modeling, non-linear modeling, has not been given over there. And maybe right now it is being done or not, I don't know, but I think for the building the best software is ETAP, in which you can have a excellent inbuilt properties, and you can utilize that. Let us say if you are using damper, there is a already link properties in which you can provide the damper also, and you have to only give the design values of that damper, and you can see the behavior of that temper. I think these properties are not available in the StatPro because I am not using that StatPro, so I am not aware. But when I used that particular StatPro, it was not available. Currently, I don't know.
Okay, sir. Sir, we
Sir,
can proceed for the conclusion of this session.
Anyone
hello,
was
sir.
asking something? Yes,
Sir,
yes, please.
I have one question. Can we use
Yes.
a STAP 2000 for non-linear analysis?
Stat.
SAP
Yeah,
2000.
yeah. SAP is the first software, non-linear based analysis. Actually, I have also already done vary analysis many analysis in SAP 2000 version 19, 18, 22. Okay, so SAP is an excellent software because why I am using ETAP, because if you are working in the building, so for that it is good. If you are doing work in any other structure like bridges, so you can definitely go for SAP 2000.
Okay, sir. Thank you.
Yes.
Yes, any other question? I thanks Praveen sir. Sir,
Okay.
this session is very informative and we learned many things from you, and even you have shared your email ID and contact number. So if
Yeah.
anyone have any doubt, they can ask you later on also.
Yes, anytime. Thank you very much,
Can
sir.
we conclude, sir?
Yeah, definitely.
Okay,
We
sir.
have
Thank
already.
you.
Okay, thank you.
Sir,
Thank you all.
sir.
Thank you all the participants. Thank you, Jiten.